Look at this footage. The image on the left is full of the ugly, crawling grain you expect from a phone in the dark. The shot on the right is clean, crisp, and cinematic. To get that look, you'd usually need a heavy DSLR and a $3,000 lens. This specific shot came from the Vivo X300 Pro. For over a century, photography has followed a single rule of optics. If you want to shoot in low light, you need a physically larger sensor. Big glass equals bright video. Take that big glass away, and a tiny phone sensor has to strain to capture whatever few photons it can find. That strain creates extreme digital noise, turning a cinematic moment into a pixelated mess. Vivo claims the X300 Pro can bypass these limitations to rival professional cameras. The question is whether this is a clever marketing trick or a genuine shift in how mobile sensors process light. If these results are repeatable, they invalidate the technical boundaries mobile filmmakers have lived with for the last decade. To understand the problem, look at the inside of a DSLR body. It's a large, hollow cavern designed to funnel light. A smartphone chassis is a crowded, razor-thin sandwich of batteries and microchips. This creates photon starvation. In video, your camera has a fraction of a second to grab light. A huge sensor drinks it in. A phone sensor gets a trickle. Phones amplify this weak signal. When software guesses what's in the dark, it makes mistakes, creating chaotic, static-like noise. You cannot solve this by tweaking the glass. The physical dimensions of a phone make it impossible to gather enough light using hardware alone. Since physics won't allow for a bigger window, the solution has to move into the silicon. The X300 Pro uses a custom architecture called the V-Series imaging chip, a dedicated brain handling heavy mathematical calculations in low light. This chip intercepts raw, corrupted image data before it is saved as a video file. It compares multiple noisy frames against each other in real time. By analyzing the differences, it identifies the static, throws it out, and stitches together a clean image. A traditional DSLR achieves this result by leaving a physical shutter open longer to soak up real light. The phone uses math to reconstruct the missing detail instead. It's a process of computational reconstruction rather than simple light gathering. But we need to see it under pressure. To test the limits of this chip, we moved into near total darkness. Our only light source is a single, faint street lamp in the distance. Initially, the raw output on the camera screen looks unusable. It's a muddy, flickering mess. In this moment, it looks like the hardware has reached its limit. But then the V-Series chip engages. As the signal passes through the processing node, the real-time denoising algorithms activate. The chaotic, spiking noise waveform we're tracking on this chart instantly flattens into a smooth, uniform line. This test shows that a mobile processing engine can use logic to replicate the results of expensive optical physics. This moves the conversation away from sensor specs and toward the democratization of high-end visuals. For years, the barrier to professional filmmaking was the cost of specialized glass. Now that barrier is being lowered by accessible software. We're seeing a shift in how we perceive the tools in our pockets. A consumer device is now capable of producing images that used to require a dedicated crew and a gear bag. This explains why the side-by-side comparison we started with looked so jarring. We've been trained to believe that clean video in the dark is only possible with a massive lens. We are reaching a point where the distinction between a professional camera and a smartphone is determined by processing logic as much as the physical glass. The Vivo X300 Pro demonstrates a significant shift in mobile cinematography. Algorithms and raw processing power are now successfully bridging the gap created by the physical limits of small-scale optics. This leads to a difficult question for the industry. If a phone can use math to solve the problem of darkness, does the traditional DSLR still hold a monopoly on professional quality? I want to know your thoughts. Is computational video a shortcut or the future of the medium? Let's talk in the comments.